Morning students, welcome to Good Samaritan School online classes. In the last classes, we were started the spherical lenses of both convex and concave lenses, and also the basic terms how to use some terms in this spherical lenses that we have learned in the last class. That means the very important thing, the middle one is the optic center, and this is the focal length of left hand side and the focal length on the right hand side, right? And C1 and C2 is the center of curvature of in both the sides, right? And you know that this is the radius of the curvature which starts from the center of curvature to the optic center. So it is for both side, okay? And the principal axis. So all these things are the basic thing that we should know before starting this topic. In today's topic, we are going to learn on the ray diagram of the refraction by spherical lenses. The main rules, three rules we are going to learn in this topic. The one is, the first one, we are going to simultaneously learn both for convex and concave lenses. Okay, let's go for convex lens. The ray of light parallel to the principal axis, after refraction, it passes through the focus on other side. As you see that this is the convex lens. When a ray of light which is incident, okay, this is the incident light which is comes from the lens, incident light which is come from the left hand side. When it crosses or when it touches the convex lens, it get refracted, okay, on the other side. That is what the main thing where you can see here on the focus, the second focal length on the other side, okay. So you can even compare with the convex lens and convex mirror and concave mirror, what we have learned in the last topics. So there what we can say that this same rule it is appear for concave mirror, okay. So I can say that you can even relate with convex lens with concave mirror and convex mirror with concave lens. So both looks even more similar. You can even look at it. Okay, let's move on to this concave lens. It appears to diverge from the focus on the other side of the lens. As you see that this is concave lens, it is a diverging lens. So what happens when an incident ray comes from the parallel to the parallel to the principal axis, it get diverges, right? Obviously it get diverges. But when you connect that, that is the extrapolate, if you do that on the other side, it actually focus on the focal length, okay. That is the one thing we should know that. Okay, you can ask me a question, sir. Here you have written 2f1 and 2f2 on the other side. See, this can also be said to be C, that means center of curvature. 2f1 can be said as center of curvature also. So why I have written f1, 2f1, because to differentiate between the C1 and C2. This is the center of curvature on the left hand side and center of curvature on the right hand side, okay. The second ray diagram is, or the rule is, the ray of light passes through the focus after refraction, goes parallel to the principal axis. You can see here when it comes through the focus after refraction, it goes parallel to the principal axis. Here also you can see that the ray of light directed towards the focus after refraction that goes parallel to the principal axis. So when it comes or through the focus, okay, so here we extrapolate it, we can say that it comes towards the focus and it goes parallel, okay. And the third one, in concave and convex lens, the optic center goes without, you can see that completely these two things are same. That is why it is written completely. The concave and convex lens, a ray of light passes through the optic center, goes without any deviation. So you can see that this is the optic center for both, and here we can find the focal length or focus, and here we have a center of curvature, can be written as 2f1 and 2f2, and here also we write the same thing here. Okay, so what happens when the ray of light passes through the optic center? So this is the optic center. When the ray of light which is passing through the optic center like this, without any deviation, it goes back, it goes directly. That is the main thing here. Here in the same, it is in the same case of concave lenses also, this will be same. So it goes. Okay, that is what is given. The concave and convex lens, both, the ray of light passes through the optic center, goes without any deviation. So it won't come back, but you can see in the concave and convex mirror, you can see that it, when it comes to the center of curvature, then it goes back directly to the center of curvature. But here in the lens, it won't happen, it goes directly. Clear? The next topic is the image formation by a convex lens and for a various position of the object. If the object is kept in a different position, then what about the image, and how the image which is formed on convex lens, and what is the nature of that image, and what is the position of the image, and how it process, and how what may be the size of it, that we are going to learn on this topic. It's the same thing for concave and convex mirror also, we have learned the same topic. So here we are going to learn on the same topic with lenses. Okay, the first thing, now the object is placed at infinity. Infinity means it behind the 2f1, that means center, or that center of curvature से थोड़ा पीछे से. Okay, think that this may be the object, whatever an object, and the object is placed here. So when an object is the ray of light which comes here, it goes towards the, yes, focal length. The same thing, why we have to take two different types of rays? The reason is we can take, we can see the ray from two different sides. That is the reason we can take two rays here. Okay, so what happens when it comes here, both you can see it combines on the focal length. So at focus, where it joins, at the focus f2, and how the size may be and how they look, the size of an image is highly diminished. It looks maybe like a point size, and they are real and inverted. Okay, real and inverted. Real means only after refraction only you can find that images, so it always comes as real. And you can compare the same, as I told you, convex lens with concave mirror. So both actually look similar. You can even go through the previous topics, and you can see that the two topics, convex lens, the image formation of the convex lens, and the image formation of the concave mirror, both looks even little similar, and how they do. Okay, they are real and inverted. Okay, next thing is just behind 2f1. So this is a 2f1, right? So now you can think that this may be the image just beyond 2f1. You think that this may be A and B. Okay, an image is standing like this. So what happens when a ray of light which is passes, it comes parallel to the principal axis. This is one of the rule, right? Parallel to the principal axis, and then goes on the focus. Clear? And the second thing, see, we, as I told you, you have to see two types. Okay, one ray comes here like this, another type of ray also comes, and that ray is comes directly towards the optic center. So when it comes directly to the optic center, where it goes like this, right? Yes, it goes like this. So you can see that you have to put an arrow mark. Even in your exam they ask you to put an arrow mark. It's very, very important. So you can see that now this is the point, and here only then image is formed. You think that A, now it become A dash, B dash. That means what? The image looks inverted. That is why I put it like A dash and B dash. Okay, so now you can see that difference. And you can even compare the image. So what is the position here? The position is from between the point F2 and 2F2. Am I right? So where is the image formed? Position of the images between F2 and 2F2, right? And what is the size? You see that, compare the image size here, sorry, object size, little bigger, right? Little bigger. And see the image size, very smaller. So I can write it as small. Size will become small. And always this convex lens, they produce a real and inverted nature. Real and inverted in nature. I hope you will understand this. Okay, we'll do one more thing also. Third one, at 2F1. At 2F1, what happens? Okay, so I have drawn all these things that you have to see. At 2F1, this is 2F1. So now I'm going to keep here A and B as an object. Okay, same thing when it comes parallel to the principal axis and goes to the focus. This is one ray. What is going to be the another ray? Yes, the other ray will be directly towards the optic center. So when it comes directly to the optic center, actually it has to come like this. It has to come like this. This won't come. So it comes here at 2F2. Clear? So I can say that you see that image size and object size and the image size, they looks almost similar. Will you able to understand this? Yeah. So I can say that what is the position of the image at 2F2, the exactly the image formed. And what is the size? The size is actually the same as the object. Okay, and you also see that it is real only after refraction only it comes. So I can say that it's real and inverted. So I cannot say like this, it should come like this. So it's A dash and B dash, right? Can I go to the next topic then? Between F1 and 2F1. Okay, let's see that between F1 and 2F1, this may be the object. So we write it as A and B. Same thing, I can say that parallel to the principal axis and goes towards the focus. And the second thing is optic center से आ जाता है. When it comes at the optic center, it goes like this. So here it comes not actually at F2, it's after, beyond that F2 it comes here. So I can say that A dash B dash is the image. So I can say that it comes where the image comes beyond 2F2, the image comes. And what is the size? You see the size of the object and size of the image enlarge, थोड़ा बड़ा आ जाता है, right? And real and inverted, right? I hope you understand this image formation of a convex lens. So I'm going to give you these two as a homework. I hope you can do these two in your home. Okay, the object at focus 1 and the F1 and the between F1 and the optic center. Okay, the next topic is the image formation by a concave lens. How the image is formed on the concave lens? First thing is, it at infinity, I'm going to keep some object here somewhere beyond that 2F1 and all. Infinity, we don't know that. So the ray of light which comes here, and after that it refracted you know that this lens is a diverging lens, so it diverges, and this lens is also a diverging, goes like this. But when we extrapolate these two rays in the other side, yes, it joins the focus of in the other side, so it comes here. So I can say that the position of the image is at f1. You can find the image. And what is the size of the image? Yes, because as we can see in the compare the convex lens also, when it comes on the focus, it is highly diminished. Okay. And what is the nature of it? Because it's not come after refraction, it comes, so we can say that this is a virtual image, and also this image is always an erect image. Okay, erect image. Okay, the next thing is between the infinity and the optic center. So I can say that infinity is somewhere here and the optic center is here, so we can keep it at any one of the places. So I can keep the image at here. Okay, whatever, you can keep it here, so I'm going to keep it here. So first thing is, yes, it goes getting refracted. Okay, this is the one thing. What is the other ray also we have learned in concave? Yes, it goes towards the optic center, right? It goes like this. But when we extrapolate this rays, so you can find here the ray meets. So I can say that this is the A and B is the image, sorry, object, and here only an image formed. This is A dash and B dash. See the image size, very small, am I right? So where it produces, where the image formed, it between F1 and O. Will you understand? F1 and O के बीच में the images comes. And what is the size? Comparing to the object, this is very small. So I can write it as very small. Obviously, because it is a concave lens, you can find the virtual and erect image. Clear? The next topic is the sign convention for a lens. Even for a mirror also we have learned the sign convention. The same thing, you can't say it's going to be totally difficult. Same for a concave and convex mirror. The same you can find it in concave and convex lens. So only one difference is that is you can see that all the measurements have to be made from optical center. That is the main thing. Optical center is, if suppose this is a lens, optical center will be like this. So measurement should be taken only from the optic center. That is the only thing. The rest of the things you can find the same will be there. The focal length of the concave lens is negative. Okay, when it comes of focal length, concave lens is always negative, but when it comes for the focal length of convex lens, is going to be positive. The distance u, that is on left, the distance of u on the left of an optic center is always negative. So whenever you can see it on the left hand side, everything will comes as negative. Whatever you can see it on the right hand side, the object distance, it is going to be, yes, positive. The next thing is the image distance v on left hand side. If the image is formed on the left hand side, it's going to be negative. If the image formed on the right hand side is going to be positive. And the object or an image or height, object or image height, that is h and h dash, above the principal axis is always positive. So below the principal axis is going to be negative. So that you can keep this as your idea, you can easily identify that. X-axis and y-axis. X-axis, you can see that all the things which is on the left hand side is going as a positive, negative, and right hand side is going to be positive. Top will be positive and bottom will be negative. The same what we have learned in the concave and convex mirrors. Lens formula also, there is no big difference in the lens formula. It's going to be the same. Only thing you can see that and you can know the lens formulas of the spherical lenses. It is the relationship between the object distance and the image distance and the focal length. So only difference is here you can find a negative sign comes between the image and the object. Only that will be the change. And in the magnification produced by the spherical lens also, you can find one distance, height of an image h dash, and a height of an object as h. So only thing, in the mirror you have learned with the negative sign, but here for the magnification of the lenses you can't see the negative sign. It just as v by u. Only that will be the simple thing. And the last but not least, power of lens. What is the power of lens? You can see that the degree of convergence or divergence of light ray achieved by a lens is known as the power of lens. Okay, as we know that concave mirror or concave lenses are said to be a diverging lens, and convex lens is said to be a converging lens. Okay, the degree of these two, when a light ray is achieved or passes through that, and through that we can identify the power of lens. That means defined as the reciprocal of focal length represented by p. So the power of lens p is equal to 1 by f. If s is given in meter, then you can use directly 1 by f. If it is given in centimeter, just an idea, you can use 100 by f. So SI unit of power of lens is always diopter, is denoted by capital letter D. That means 1D is equal to 1 by 1 meter. In other words, it to be 1D is equal to 1 by 1 per meter. Okay, that means inverse. So this is what power of lens and the formulas. While we do the numericals, you may understand even more on that. So we'll start with the numericals. You can take down the first question. A concave lens of focal length 15 centimeter forms an image 10 centimeter from the lens. Okay, so the focal length is given 15 centimeter and the image formation is on 10 centimeter. How far the object placed from the object? So they are asking about the object, how far it is placed. So, and you have to draw the ray diagram also. So first of all, we can say that f, the focal length is given is 15 centimeter, and why we are writing it as minus 15 centimeter, as we know that this is a concave lens. Okay, when you see a concave lens, this will be the diagram of a concave lens. You can see that always the image comes on the left hand side only. When an image comes on the left hand side, it is always going to be negative. So the focal length will be always in the negative. That means on the left hand side. So V is also given, the image distance, the 10 centimeter, and U we have to find. So according to the lens formula, let's draw the diagram where it makes. Suppose somewhere this object is placed, and this distance is 10 centimeter object distance. So when it passes the optic center, it get refracted. That means diverges. And also the other ray goes towards the optic center. So when we extrapolate this, it comes like this. Somehow here the image is formed, and the image is an erect and virtual image that we know already. So here you find that lens formula. What is the lens formula here? 1 by V minus 1 by U is equal to 1 by F, right? So we need only 1 by U, so I can take that 1 by U and keep the other on the other side. So substitute all these things what we have in our hand. So V we have, so write it as minus 1 by 10 minus 1 by minus 15. Clear? So when we do a simple calculation, what we know, it comes as minus 1 by 30. It comes as minus 1 by 30. So this is actually 1 by U. So if I write U, it is minus 30 centimeter. Am I right? So how far the object is placed from the lens? It is minus 30 centimeter. The other simple numerical is to find the focal length of a lens of power minus 2.2 diopter. What type of lens is this? So use the power of lens formula, but here they have given minus 2 point d, so you have to find the focal length. So I need only f, so I can write it as f is equal to 1 by p, right? So when we substitute this here, 1 by minus 2, that is the power of lens is minus 2, so it comes as 0.5 meter. Am I right? It is actually a negative sign. So that is focal length is negative. If the focal length is negative, then what it have to come? On sign convention we have learned, if the focal length is negative, then it should be a concave lens. So the answer for this is a concave lens. Okay, the other question that we will see now, a doctor has prescribed these two. Can you do these two as your homework? The question number 3 and question number 4, which is given here. Please do these questions as your homework. If you can't do, please let me know so that I will try to help you in the other class. And this is the end of this chapter, student. Hope you understand this. If you have further doubt on this topic, please do ask me in my WhatsApp number. And thank you and have a nice day.